Thank you for joining this webinar. This webinar is about finding the story in choice-based conjoint studies. As always, I'm presenting from within Displayer as it's designed for data storytelling. But for all the Q users out there, you can do everything here, but some of the graphical interactive simulators and stuff, you have to do via code. We will send you a recording of this webinar. We're doing a deep dive, looking at Conjoint over 5 webinars, and we're at webinar number 4. Now, in webinar number 3, we looked at how you calculate utilities and how you create a simulator. And today, we're going to look at how you use this data to find insights. What's the story? If you've got any questions, type them into the questions field in GoToWebinar and do it as we go. If I've explained something badly, I'm keen for you to jump in and get me to clarify it rather than waiting for the end. It's a difficult topic. The first half of finding the story is all about prediction. And the second bit is trying to explain those predictions or explain that behavior. And we use slightly different techniques. Not slightly different, we use different techniques for each of these stages. In the previous webinar, we focused on a case study looking at job choice. Rather than look at all the data, I'm actually going to look at a subsegment of 454 respondents who are people who are able to do their work from home. And I'm focusing on just this segment because when we reduce the data to just this segment, we get a bit of noise. And that makes the challenge of interpretation a little bit harder. So hopefully it'll be more interesting to look at. In the previous webinar, we talked about how you take each person's utilities and you scale them. So the lowest level attribute, that is the least appealing attribute, has a utility of 0. And you'll see here that this hasn't happened on this chart, or it doesn't seem to have happened more accurately. So here, the least appealing salary is current, and it's got 5 rather than 0. And I'll return to that conundrum a bit later. It's much easier to read utilities as a chart. The traditional way of showing utilities is via a line chart like this. Now, our lowest level of utilities aren't at 0, and this makes this line chart look a little bit weird, so I'm going to scale it again. Just dragging each of these lines down to have a utility of 0 for the lowest or least appealing level of the attribute. When we look at our first attribute, which is salary, we've got our first really cool insight. The utility or appeal of a 10% pay rise is 6 times more appealing than the utility of a 5% pay rise. So 5%, meh. 10%, now we're talking. The next attribute looks at employers' plans to become carbon neutral. And we see that the greater the commitment on average, or the sooner with which the organizations plan to be carbon neutral, the happier people are. But there's some little irrationality here. A 20-year commitment has got marginally less appeal than a 30-year commitment. Doesn't make sense, does it? Being currently carbon neutral is less appealing than being carbon neutral in 5 years. Again, it doesn't make sense. This is completely to be expected. All surveys contain measurement error. Conjoint surveys are boring, so they contain more measurement error than most. Now, the reason we're seeing the measurement error here is because carbon neutrality is a relatively unimportant attribute for this segment of people. When I say unimportant, I'm talking about the difference between the highest utility level and the lowest utility level. That's importance. So it's lower for carbon neutrality. And the less important something is, the more the noise in the data becomes obvious. So we've got the same level of noise likely in all of the attribute levels. It's just less obvious because the utility difference between the levels is greater. This next result's fascinating to me as a software person, which is the difference between having poor software and standard software is a utility of about 30. And a utility of about 30 is roughly equivalent to a 13% pay rise. So for all of you people out there with bad software, employees really, really appreciate being able to be productive at work. Mastery, to use the language. can be provided by nice software. It's a result. I'm not trying to sell, of course. And the last interesting thing that we see here is our location attribute. The more remote people are, the higher the utility. So working from an office full-time is the least appealing, 50-50 more appealing, primarily remote, which meant come to key meetings in the office. More appealing, again, fully remote the most, but it's diminishing, right? We don't get a benefit from each one. That's equivalent as we increase the level of remoteness. Column and bar charts are perhaps the more modern way of showing utilities. Here's an example from a study that we've shown before in earlier webinars, looking at 2-ounce chocolate market in North America. Now, a practical problem with showing utilities is the scale is arbitrary. On the previous page, I'd scaled each person's utilities out of 100 to make them easier to read. In the earlier webinar, we talked about how the natural scaling, or the scale with which utilities are actually estimated, is something called a logit scale, which is what I'm showing you here, but they're both arbitrary. One way of scaling is something we've already kind of touched on when I compared the utility of software versus salary. We can scale using one of the attributes. And the most common one to do is price. And when we do it, we're calculating something called willingness to pay, or equivalently, a dollar metric scaling. Now, the way it works is this. You find your price attribute or one of your numeric attributes. I said price is most common. You work out the difference between the highest and the lowest levels. So 249 minus 99 is a difference of $1.50. And then you calculate the utility of that difference. So $1.50 is worth 1.48 utilities. Using some very simple math, we divide both sides by by 1.48. We get one utility is worth around about $1.01, or approximately $1 to make our math very easy in this case here. So this tells us that we can see that, for example, the difference between sugar-free, which is indexed at 0, so thus has utility of $0, relative to standard chocolate is $1.46. Milk chocolate versus white, $1.33. This approach is often referred to as brand equity because we can now put a dollars and cents number on different brands. So Hershey's utility relative to Lindt is $1.12. When you first see this approach, you tend to fall in love with it. It just seems to tidy up everything, but it's actually not a very good approach in real world situations. To see why, let's have a little look at the sugar attribute. If you look at this, it says, okay, standard sugar levels are worth $1.56 more, according to this approach, than sugar-free. So, flipping it around, if we were to launch a sugar-free chocolate, this perhaps implies it needs to be $1.46 cheaper than standard 2-ounce block. Now, a standard 2-ounce block might only be $1, so now we've got to pay people to take our sugar-free chocolate, which obviously doesn't make sense. But if you think about it a bit longer, or more importantly, if you've purchased sugar-free chocolate, you'll know it always costs much more than standard chocolate. So it's a complete opposite of this. What's going on? Well, in the real world, we have segmentation. These are just showing averages. And that's very misleading because when you're trying to price something like sugar-free chocolate, you just want to sell it to the people that want it a lot. And so you'll get exactly the wrong interpretation about pricing from this visualization and this calculation of willingness to pay or dollar metric scaling. And there's a second problem, which is a little more subtle and complicated. The technical meaning of this $1.46 is that if you could charge every person the most they would possibly pay, the average price you would charge would be $1.46. Now, in the real world, we don't know how much each person will pay. We also don't have the ability to charge them each a different price, so we definitely can't even get this $1.46 number. It's impossible for us to get. Furthermore, there are competitors which are completely ignored, which will reduce the price. So my advice is do not scale the utilities this way. All it can do is lead to clients drawing the wrong conclusion. I had an earlier career as an expert witness in court cases, literally just usually looking at this exact same type of analysis and going, no, they misread the chart. We talked about how to create simulators in the last webinar, but they're the fun stuff. So we'll look at how we use the simulators. From our job choice data, I've created a simulator comparing two offers. Now, one of the motivations for doing this study is my own motivation of wanting to understand what kind of policy our organisation should have in terms of remoteness of work. And so I've put here on both sides our current, not quite our current, but a common current situation, which would be not planning to become carbon neutral, using poor quality software, fully remote. And you can see here we get 50% preference because they're identical. So to use the jargon, a consumer will be, or an employee will be indifferent between them. Okay, now a lot of companies are saying, you must come back to work. What happens? Simulator's warming up now. We're going to soon find out that, all right, so only a third of people would choose an office where you have to come to the office every day. 2/3 would prefer to be fully remote, all else being equal. Now, this means that if we change our policy, we're going to make people less happy. And if we're trying to recruit new people and we insist they work from the office, we're going to have fewer people who will join our company. So what do? Well, we maybe try and offer some inducement, a pay rise. No, 5% wasn't enough, but we saw that before from the utility data, right? What about 10%? Still not enough, 15%. Okay, so if we want people to return to work, the price for that to make them on average not feel inconvenienced is a 15% pay rise. It's North American data, it's a representative geographic sample. Now, simulators work great when you've got a specific set of scenarios you want to run, like I have here. A different situation, which is pretty common, is when you have lots of scenarios you want to run, too many to look at. To do this, you create something called an optimizer. Now, this is how we create the simulator as well. I click on the output from my model and I go into simulation and click optimizer. I'm going to just do two alternatives again. And now display will build for us an optimizer. Okay, now let's make it a little bit more readable. Okay, so I'm going to modify this to look as we had before. So we're comparing fully remote with work in the office every day as the two alternatives. As we saw before, we're going to get the preference share of 1/3 of people preferring the option of work from home and 2/3 preferring the fully remote, all else being constant. Now, we manually went through all of the price points before, or price, I should say salary points before, but the point of an optimizer is you just get the software to automatically go through all of the combinations and just create a table showing the results. And so these are the different simulations that we get. We manually created these before, the optimizer automatically does it. Now, if you plot these, you have something called a demand curve. And demand curve is the first classic output of these types of studies. When I say first, it was the first that was invented. Now, here we're looking at, and this is a slightly unusual one because we're looking at the extra salary, which is a price. It's kind of a bit backwards price. That's a bit confusing. Here I've plotted those results from the optimizer, and you can see here that the more salary we get, the more demand we have for that option of working from the office. And if we interpolate, we can see that around about a 14.5% price rise is at the point at which people become indifferent from working from the office versus being fully remote. So here is a demand curve for sugar-free chocolate. Now you'll remember that the willingness to pay suggested that sugar-free chocolate was a real bad idea. But what we can see here is At a 0% price premium, that is if we sell sugar-free chocolate or low sugar chocolate at the same price as fully sugared chocolate, we're going to get about a 31% of people preferring the sugar-free chocolate. That is, it's less appealing. But notice we can raise the price by $1, and raising price by $1, we've still got 20% of the market. We raise the price by $1.50 and we've $1.49, and we've got 16% of people still in the market. So there's very clearly a segment of people who are prepared to pay quite a bit more for the sugar-free chocolate. Hey, Lou has asked, can salary be OV'd to the y-axis? Okay, yeah, so in the world of showing demand curves, there's two ways of doing it. Sometimes you show price on the x-axis, sometimes you show price on the y-axis. The difference really comes down to whether you're a scientist or an economist. One tradition likes to do it in one way, the other way. The economist will tend to do price on the vertical axis. In science, you tend to put your causal variable on the x-axis. It's the same information, just flipped around. Let's return to our little optimizer. So we looked before at just seeing the effect of playing around with salary, but now let's run a simulation where we also optimize for carbon neutrality. Tidy this up just a little bit more while I think. All right, now I've run 30 simulations. Let's drag this table down a little bit to have a look at them, and we'll sort. So we get up to 62% preference for working in the office if we give away is the wrong word, sorry, if we reward the team with 20% higher salary and commit to being carbon neutral in 5 years. Now remember, we know before that carbon neutral in 5 years has probably got a bit of measurement error, and so probably we're actually better off being carbon neutral, but the difference between them is small. So we looked at demand curve as a way of summarizing a single attribute, optimize the results. An indifference curve does it for 2 attributes. Let's have a look. Here we're looking at, on the x-axis, how many years the company will take to become carbon neutral. On the y-axis, we've got the salary increase. Now, this far left bit of the curve is actually the same information as our demand curve. The way we read it is if a company's got no plan to be carbon neutral and is offering a 0% salary increase, the proportion of people who will prefer that compared to working from home is around 36%. It's a little under 36%. If we increase our salary, so we've still got no plan for being carbon neutral, we increase our salary to say 10%, and we follow this along. It's a little bit hard to read, but we're seeing about 46% preference. If we go all the way up here to 14.5% pay rise, we're now seeing this little line here, which we follow across, is our 50% preference, so our point of indifference, and this is called an indifference curve. They're kind of cool, aren't they? Now, when we follow this indifference curve down, we can see that if we actually offer an 11% pay rise and a company that is carbon neutral, we're going to get the same preference. So an organization go, well, we'll pay people 15 or 14.5% more, or maybe we pay people 11% more and become carbon neutral. It'll have the same overall effect in terms of preference for people working from the office. Now, some of you might go, oh, there's a bit of an insight here. You can actually see that if we offer the 5 years, we can get away with just a 10% pay rise. And that's true based on the data, but that's capitalizing on measurement error. I wouldn't recommend doing that. But you could certainly take the approach that we should go 5 years because we've got no data to suggest it's worse than the already carbon neutral choice. Here's another set of indifference curves. This one here is looking from a study on home delivery choice. We're looking at restaurant quality versus price per diner. What we can see here is that if, for example, we have a restaurant quality of about 4, follow that along, at $10, that's got the same appeal to being $17 at 4.7. So if a restaurant can lift its restaurant rating on Uber Eats or whatever from 4 to 4.7, they can charge an extra $7, or in this case 70% per diner, which is a big benefit. So we're starting to get some quite interesting insights out of this. This one's looking at utilities. You could also do it using preference proportions as we did in the previous example. Now, earlier we looked at the average utilities. The next step is to look at distributions of those utilities. Now I've zoomed in here, just looking at the range of utilities from 0 to 11, because I want to explain something we saw before, which was even though we scaled each person's utility to have an average of 0, each person's utility to have a 0 for the least appealing attribute level, for salary, this average is 5 rather than 0. And the reason for this is when we zoom in, we have some variability. So if people didn't think salary was important, we're going to have noise in the data, and we're going to have situations where some of the other attribute levels will have a higher utility, and we're going to have a range in the utility for the current. You can see here the most common phenomena result is that people do have a utility of 0, but there's a small number of much higher utilities, and so it averages out at 5. So that explains a little conundrum we had before. We have bumps at the end of each end, bump at 100, bump at 0 for many of the attributes. The bumps are caused by scaling because we scaled the data to be in the range of 0 to 100. The one that's clearly bimodal, that has two very distinct bumps, is being fully remote. There's a segment of people who want to be fully remote, and it's the most important thing for them in the whole world, well, of all of the attributes we've tested. And there's another segment who do not want to be fully remote. That is, they want to work from the office, and it's the most important people for them. Note here that for salary, we've got our biggest bump for salary growth at 20%. It's a little hard to see here, but we've also got our biggest bump with very little variability for current, and these much broader bumps in between. That's because these are showing the variations between people in terms of things, and so showing it's the middle level attributes which tend to emphasize the differences between people. So the next step in understanding behavior or explaining behavior is to look at correlations. I've correlated each person's utilities for the job choice data. And I've got a couple of questions coming in. Lou has asked, what about showing if there are 3 attributes? Yeah, there's no great visualization for 3 attributes. Now, when you can theoretically do a 3-dimensional visualization, a 3-dimensional indifference curve, but in reality, we can't look at it because screens are 2-dimensional. So what you tend to instead do is you can do slices of these things. So have one indifference curve for one level of an attribute, the next level of the second attribute of the third attribute have a second indifference curve, and so on. Or you can look at correlations, which is what we're looking at here. Jer, apologies for, I'm sure, the mispronunciation, says, can I build indifference curves in Displayer or only in Q? No, you can certainly build them in Displayer. The code's the same. So Displayer and Q are very similar products. It's just that Displayer is also designed for reporting. So there's nothing you can visualize in Q that you can't also visualize in Displayer, but you can't do the interactive things in Q that you can do in Displayer. All right, back to our correlations. Now, there's a couple of standard patterns you always see when you do a correlation matrix of utilities. The first one is that the main diagonal, which is this big line down here, is always got 1s because there's a perfect correlation between the utility of my current salary and itself, because that's all that we're seeing here. So that's not interesting. The interesting pattern, the first one, or moderately interesting, is you'll tend to see that adjacent levels have relatively high correlations. So the correlation between 5% and current salary is moderately high. And I say relatively high relative to all of the other correlations. And this only applies for ordered attributes. But you'll see here that most of the second levels are blue, meaning there's a positive correlation. That's that effect we're talking about. The next common thing you'll see is that when you have an ordered attribute as well, you'll see that the most and least appealing alternatives or levels are going to have a negative correlation. So there's a negative correlation between the utility of a salary increase of 20% and the current salary. And this is because, or it's not, because it's telling us that, not surprisingly, the people who really value a 20% salary are not the same as the people who really don't care. Now, so they're the basic rules for interpretation. What are the interesting things that are jumping out? There are a few little things to call attention to here. Just talked about these two. The first one here is we have what's called a segmentation pattern here, clustering if you like. This is showing us that the people that value no plan the most are the same as the people that value 30 years and the same as the people that value 20 years. So there's evidence of a segment of people in the data who are all sharing their views about this, and that is the people who like it, like all of them, the people who dislike it, dislike all of them. The next thing that really jumps out is down here in the bottom right-hand corner. We're seeing a little, and it's weaker than that one above, we're seeing a little segmentation in terms of office, hybrid, and primarily remote. So if I'm willing to come to the office, or I kind of like or dislike any of those, I'm going to dislike all of them. And then we get this strong negative effect for fully remote. So if I really value fully remote, that means I really do not value working from the office, and vice versa. Lou says, are these Pearson's correlations? Would non-parametric correlations be better? I don't think so. So the data here is technically measured on an interval scale, which is the assumption of a Pearson correlation. So I don't see an advantage in doing a non-parametric correlation. Also, the data is not remotely categorical. The underlying utilities are, all scaled in a 0 to 100. There are some technical types of correlations that you can do for compositional data, which is the statistician's name for data that's kind of bound within a range such as 0 to 100. But their assumptions aren't even met for this data here because each person's got a different scaling. I tend to find, though, that changing correlation metric only works in situations where you've got something really wonky or weird in your data, like, data in the range of 0 to 1, except one person who said 99, and that tends to be measurement error anyway. Now, the next type of technology is something called a substitution map. And these are particularly useful when you have an attribute with lots and lots of levels. So utility tells you which one's most preferred, but a separate question is which ones are substitutes for each other. This is a quite technical topic, so I'm not going to describe how it's done because it's actually not widely useful, but sometimes it's useful. Here I've got one from that fast food study, and the way we read this, it's telling us that if I can't get pizza, because maybe it's too expensive, then I'll most likely to switch to chicken or Chinese or Mexican in this particular market. Very unlikely to switch to Indian or hamburgers. Now, the next thing to have a look at is within attribute clustering. The basic idea is that we use cluster analysis. I'm going to choose good old k-means. And we just cluster for the utilities of a single attribute. Now I'll hover over these so you can see these utilities for salary, and you can see this is all very numeric data going back to Lou's question about what type of correlation to use. So I'm just going to choose my salary levels. So I just choose the utilities associated with a single attribute, and we're going to use cluster analysis just of those. And this is a great way to find out the distribution of the utilities within a single attribute. Now, with two clusters, which is the default, we're finding here that cluster 1 have really high utility. Remember, the highest they could have is 100, which is if everybody found this the most important thing. They've got a high utility of 86. And we see lower levels of price, or not price, lower levels of salary equate to lower levels of utility, so that makes a bit of sense. And as we talked about before, this 10% is much more appealing than the 5%. And if we look at cluster number 2, we can see that a little over half the sample, we can see that they've got broadly similar utilities for all of the levels of salary because it's much less important to them. So we've got people who care a lot about salary, people who care little. Let's go to 3 levels. At 3 levels, we end up again, and this is the same segment we found before, but it's moved from the left to the right, one cluster who really value high salaries. We've got another cluster who don't care much, but the more the salary, the happy they are, but their overall happiness is much, much less because salary is not what motivates them. Because we'll scale the data out of 100, it's going to be something else with much higher scores. And then we get this other weird little segment here, which is people who've actually got the highest utility for, or the lowest utility, sorry, for the highest level of salary, which makes very little sense to us. Now, what's causing this? The first thing to note is it's only 10% of the sample, less than 10%, 8.6%. The second thing to note is when you cluster data, you always get weird little artifacts in the clustering because it's just, there's a whole lot of math behind this, but you're basically always guaranteed that you're going to find something a bit weird. Now, this could be an insight that 20% is just too much. I haven't met those employees, but maybe they're out there. Maybe it was a way that people were signaling that 20% was greedy when traded off against environment, but my guess is it's just noise. So we can do that same approach. We'll get a more interesting answer than salary if we look at the location attribute. Okay, so here we've got 3 segments for location. There's a group that really want fully remote, and they've got half as much appeal for primarily remote, and hybrid similar. Then we've got another segment of people that they really want to be in the office, and then but they're all primarily remote or hybrid. They really do not want to be fully remote. They need human contact. And then a third segment who the whole attribute is much less important. And again, we can keep increasing the number of clusters to get more insight from that. It's sometimes useful to summarize all the utilities into a smaller subset, which is referred to as importance scores. Now, here's the utilities plot we looked at a little bit earlier for the chocolate market here. We calculate the difference in utility from the least appealing to the most appealing level, and that is called the importance score. So looking here, we say that price is most important, followed by the sugar level, cocoa strength, brand, so on, with ethics being least important. Now, some people criticize this type of analysis and they say, well, you've lost some information. Yeah, that's the whole point. This is data reduction. It's one of the fundamental principles of data analysis. You take more data and you create less data. There's an additional benefit here of calculating utilities, which we'll come to shortly, which is when you're doing segmentation, the more variables that you have for a particular attribute level, or the more levels you have of an attribute, the more likely that attribute will be to dominate the segmentation. So in our study, if we looked at these things here, we'd find that cocoa strength was more likely to be important in our segmentation. That is, we'd have segments different cocoa strength, price, than we would due to ethics, simply because we have more attribute levels. Now, another criticism of importance scores is that they're arbitrary, and this is very true. The importance of price is because I tested a broad range of price. If I'd only tested $1.99 and $1.49, we'd find that price was very unimportant, and that's true. A way of fixing for that is to focus instead on importance scores, or create importance scores that are pertinent or relevant to your client's problems. So let's say that we're trying to work out that our client's main product is Godiva. It's standard chocolate, standard sugar levels, dark chocolate 249. We would then calculate importance just based on the likely changes they'd make and say, okay, price is very important, sugar levels are very important, but if they're already dark chocolate, well, they're clearly not going to introduce a worse chocolate, so the utility of the milk is only going to be 9. Brand, obviously a lot they can do with. If they've got no nuts, well, maybe they could move to almonds, so its utility is only 16, or the importance is 16. So these are importance scores, and you do them because it makes it easy to do segmentation. Now, when we talk about segmentation, there's 2 basic things that we do. The first one that we do is we cross-tab everything, and so let's do that. Now I could cross-tab everything by the utilities of the attribute levels or the importance scores. Oops. Now I've got to click on my data here, not so clever. And let's do that again. So I'm going to cross tab in my rows. I'm going to have all of my demographic type variables. In my columns, I'm going to do the importance. As I said, I could do the utilities as well. So I get a whole lot of cross tabs. I'm going to sort these by significance. All right, so the first and the strongest relationship we've got between our utilities, which is shown in the columns, and these are the importance of salary versus carbon neutral versus software versus being remote. In the rows, I'm showing the type of personal actions a person's currently taking to reduce carbon emissions. And what we see here is the people that are taking no personal actions have got high utilities for salary, software, or remote, or putting it another way, they've got lower utilities for being carbon neutral. Age is really quite interesting, I think. What we see here is that the carbon neutrality and salary are common across all of the ages, but it's the older people who are caring a lot more about software and being remote. Anyways, lots more detail that we can dig into there and find interesting results. The last approach is do a k-means segmentation again. And you can use any of your clustering techniques, of course. Whoops. And you use all of the utilities or all of the importance scores. I would always do both and see which one was more insightful. And so we've got two segments here. So we're finding one segment of people whose highest utilities for remote, and the second segment of people whose lowest utilities are negative, which you haven't seen before, is for remote. So they really want to work from home. Their segments are similar in most other ways. So if you were going to have two segments, it would be about remoteness. We could increase that and play around just like we would with any other study or any other segmentation. So we've looked at how you predict behavior and how you explain that behavior. Soon we'll send you a recording of this. Our next webinar is going to be on conjoint reporting. So you've done your analysis and you've got the basics of your story. How do we package it up and communicate it as a great interactive presentation? What questions have you got? And Lou is going crazy here. How is the R-squared interpreted? And you're not crazy, sorry, Lou. The R-squared in this, so when we're looking at the k-means segmentation, the R-squared is just showing us which variables, which are shown in the rows in the k-means segmentation, are strongest in terms of differences across the columns. So it's showing us here that with this segmentation, it's primarily driven by remoteness, followed by salaries. Now, technically, the R-squared is from a linear regression predicting the variable remoteness based on the cluster membership. And Lou asks, how do you select the right number of clusters in k-means? You use judgment. If you love to use statistics that are very unsound, you can use the Kalinske-Harabas. The problem of working out the correct number of clusters in k-means has been a topic of study for about 60 years. There's two groups of people. There's people that are trying to solve it as a statistical problem, and there's some advances have been made in this in recent years, but it tends not to work. The other approach is use common sense based on the strategic usefulness. And I've got a whole webinar on this on market segmentation, which talks about it. It's a topic I'm very passionate and interested in. The key thing you've got to appreciate with using automated approaches to selecting the number of clusters is all the automated approaches assume that your data has a small number of clusters representing some small groups of people in the real world. And the problem with that is in the real world, there aren't real clusters. There's infinite amount of variability between people. So when you use automated clustering techniques and use automated techniques to choose the number of clusters, you're starting by making a bad assumption. Anyway, but a whole webinar on that. What other questions have people got? And while I wait to see if there are any more, a quick advertisement. If you've liked what you've seen and you're not a currently display user, well, book a demo. Let us show you why you should be. And I think I've had all the questions. So thank you very much for those of you who are our customers, for being our customers. For those of you who just joined the webinar, hopefully you got some value out of it. Bye now.